I feel kind of sick. Like, really, really physically ill.
Okay, we are live.
We're live.
I think. We're just waiting for it to come through.
Yeah,
Nice.
looks good to me.
Okay.
I'm going to check on my phone.
Welcome to the live stream for the Gryphon II launch. Today, LURA is going to be aiming to break the UK amateur high altitude record. We are live, we're going? Perfect. Okay. We're currently sat at the top of a cliff in Cape Wrath, northern Scotland, watching the ground crew prepare the Gryphon II into our custom Sentinel silo launcher. As you can see, we have a little bit of mist coming in on the launch site, but other than that, conditions are looking pretty good. So we're just going to be watching this for the minute and keeping an ear out for the radio. We are at somewhere about T-minus 40 minutes away from launch.
Yep.
So as we wait for that, I guess we should do introductions.
Yes, yeah.
So Evan.
My name's Evan Madaroy. I am ground station lead today here. So I also work in avionics. So I'm going to be the one reading the telemetry and getting the live feed of the data as it comes off of the rocket.
And I am Theo Yudes. I am LURA's original founder a few years ago, and they've got me back to commentate the live stream today. It is fantastic to be here. We started this project about 3 years ago when I was still at university, so being able to come back now and see the guys loading the rocket onto the pad, we are just moments away from hopefully taking the student altitude record. So although it may seem quiet now, that's because, as you can see, we're loading the rocket on. The rocket is fully assembled at this point, and so far everything's looking good with our avionics. We are on time for probably a 3:35 launch at this point. So if you're not aware with what we're trying to do today, the Gryphon II is a single stage solid rocket. Today we are hoping to take the UK amateur altitude record and fly to 43,000 feet. Now, aside from being the highest amateur flight in the UK, it will also be the first time a UK team, as far as we're aware, have attempted a sea recovery of a rocket.
Yes.
Do you want to tell us about what's gone into that, Evan?
Yeah, so a long time ago, more in your era than my era, decision was made that Gryphon II would be launched in the UK. This is somewhat unusual, actually. The previous record holders, both of them, both set by the University of Sheffield and Durham University, were set in the US at the Friends of Amateur Rocketry site in Nevada, I believe. So, you know, that's perfect launch conditions. It's the desert. It's legally an easier environment, but a decision was made that Gryphon II would be launched in the UK. A decision that we've stood by for these years that has been worked on. So as part of that, the decision was made to recover it from sea rather than from land, because it would be much easier to find a site that would allow us to launch into sea. And lo and behold, it was. It took a while, but we have found a site. We are here in very, very north Scotland, ocean behind us.
And G2, this is Harvey.
Yeah.
Everyone at G2 is quite busy. Just stock
So
integration.
yeah, it'll be very interesting. We're kind of trying to start a wave. We're trying to inspire people to try and launch more rockets in the UK. That was primarily the goal here. So lots of firsts.
Absolutely. I keep glancing behind me because we can see the North Sea, where we have
G2, are you ready for the rocket?
waiting for the recovery in about half an hour's time. We're just going to keep an eye out now. We've just heard the radio call that they will be finishing the G2 loading soon, so we're just gonna quiet down and see what happens there. So we've just heard that they're ready to finish the load. At the moment, the silo is horizontal and they're going to be hoisting it vertical, ready for flight any minute soon. So we'll keep an eye out for that.
Right, catch that, what did you say?
We keep asking if you are ready for G2 yet. Or can you please give us an ETA on when we can bring G2 over, because we are ready to go now. We are ready to go.
For 5 minutes.
What is the issue with Sentinel?
We are literally just finishing up now.
I've just realised that I'm not going to see the launch.
So by the sounds at the moment, as we monitor weather conditions, launch weather balloons, and stay in contact with the Ministry of Defence running the range and with our recovery boat out at sea. We're adjusting the heading of the launch rail to ensure that...
Miss Tom, this is Jack. Are you ready to post an Instagram by any chance? If you have data? Or if you have Wi-Fi, please.
Yeah, we are constantly adjusting the heading to ensure that we give the rocket the best chance possible as landing close to our recovery boat that is waiting to fetch it out of the ocean soon. So, if you're not familiar with where we are today, we are here right on the north coast of Scotland in a place called Cape Wrath. Currently we are streaming to you from the very top of this cliff-marked ground station on the right of the slide, and we have an incredible view over the launch site a few hundred meters away and the North Sea behind us, where we have a recovery boat waiting to retrieve the rocket.
Sentinel, we are bringing G2 over right now.
Okay, so that's the confirmation that the Gryphon II assembly team are going to be bringing the Gryphon II over to the Sentinel. They will approach from the right of the screen. They have been assembling the rocket in a nearby building. So the Gryphon II team have just come out of the assembly building. They're walking over to the Sentinel. There's over 150 meters between the launch site and the nearest building, so it will just take them a minute to walk over. We can see them from where we are, and they'll be entering the shot soon. If you're just joining us, we're about T-minus 30 from the launch. I'm Theo Yudes, LURA's founder, and sat next to me is Evan, our ground station lead, who's going to be monitoring the rocket's telemetry during flight, keeping us updated with what's happening and ensuring that all the crews on the ground and our recovery team out at sea are aware of where the rocket is and are in a position to recover it.
Tyler, this is Harvey, over. Tyler, this is Harvey, over.
What we can see now is the Gryphon II team bringing the G2 into the launch rail. With any luck, the next time it leaves this launch rail, It will be accelerating to speeds of 2.5 times the speed of sound at an altitude of 43,000 feet, which will officially take the UK amateur altitude record. We've just been taking a look behind us at the ocean. The sea mist has cleared out, the waves are completely calm. There's a light breeze moving out to the east, and we've accounted for that with the heading that we'll be launching the rocket at. We have been running hundreds of simulations in the last few days and constantly adjusting the launch site in order to ensure that we have the best possible chance of recovering the rocket out at sea. Now, the reason that we are so focused on the recovery of the rocket is because in order to get the UK amateur altitude
Harvey, this is James.
we need to
James, this
be
is
able to
Harvey,
recover the
over.
rocket in one piece, ready to reuse.
On course for a 3:30 launch. I repeat, are we still on track for a 3:30 launch?
James, this is Harvey, over. We are probably going to be more looking at 3:45, to be honest. I think we'd rush things if we got it done in 10 minutes.
We are. Okay, Ross asked me to ring him back at 3:20. I'm going to give him a ring and give him the news.
Yes, please do that. Thanks, James.
Okay, so what we've just heard there is that we're currently on track for a 3:45 launch. So if you've just joined us, we are T-minus 25 minutes from launching the LURA Gryphon II rocket to an altitude of 43,000 feet. As you can hear, we have the radio hooked up to the live stream, so you'll be hearing absolutely everything that our teams on the ground will be hearing throughout the countdown and the launch. Hopefully over the next few minutes we'll be introducing you to a few bits of the terminology, and during the launch we will shut up and just let you listen to the radio calls.
Bye-bye.
We've just been liaising with the Ministry of Defence that run the range, letting them know our estimated timings and ensuring that there are no boats downrange in the danger area.
Theo, can I go on the radio?
Avionics, this is Cliff Comms. Where are we at? Confirmed that no flight computers are powered. G2 is inside of Sentinel. We'll be raising soon, then doing checks. No flight computers are powered. Confirmed, thank you.
Okay, so we've just heard that we are doing final checks with the Gryphon II rocket inside the rail, and we will be going vertical, ready for launch any minute now. A few bits of terminology that you might be hearing on the radio. So we have Sentinel is our launch rail, where the Gryphon II is currently being mounted. Cliff Comms is where we are sat right now, and it will be Evan, who's sat next to me on the radio, that you'll be hearing. He is responsible for monitoring the rocket during the countdown and during flight, tracking where it is, how fast it is, and where it is likely to be landing so that we can direct recovery. Our mission director today is Morgan. He is keeping track of many different simulations, the countdown, and ensuring everything is running on time and safely. The other voice that you'll be hearing regularly on the radio is Harvey, our vehicle director, who is responsible for everything going on with the Gryphon II at the moment. This is likely to be the last sort of slow bit of the countdown. And once we have the vehicle vertical, we'll progress to a go-no-go check, ensuring that every person in the team is ready to move forward with arming the rocket's avionics systems and recovery systems, and at that point we will be minutes away from launch. Now we're going to be keeping an ear out on that radio, but in the meantime, if you're not familiar with the Gryphon II, the Gryphon II is a 27 kilogram, 2.9 meter long solid rocket. It consists of a few key components, including a 3D printed aluminium fin can with carbon fiber fins. The rest of the construction is carbon fiber body tubes with custom aluminium coupler system that makes this rocket quite unique, easy to assemble and extremely modular. We'll be flying on an N5800 solid rocket motor today, and really the heart of this rocket is our custom avionics system with custom built flight computers and an array of commercial off-the-shelf flight computer systems and telemetry systems that allow us to keep track of the rocket during its flight and retain the data afterwards, which is a really important step, as we'll be needing to prove to the UK Rocketry Association with that data after the flight that we have beat the altitude record. So although today we hope to reach the correct altitude, we won't be able to fully verify whether we've beaten the record until that's been signed off by the UK Rocketry Association, and we'll be keeping you up to date with that as that happens. Now fortunately I have Evan sat next to me, who works at the ground station and is an avionics engineer. So he's going to hopefully introduce us to some of the avionics systems over the next couple of minutes.
Hi, yeah, so there are four main flight computers on board at the moment. We have our primary flight computer, which is a Silicdyne Fluctus, which is a great flight computer made by a company in France. Really, I love that flight computer. It's a joy to work with. The software's great. It is a very advanced flight computer with all the settings you could imagine. That's the one that we'll be receiving most of the data from, and the data that you potentially see on screen will be coming from the Fluctus. And it will also be the primary flight computer in charge of deploying the 2 parachutes on the rockets. We also have a flight computer called a Easy Mini, which is made by an American company called Altus Metrum. That does not do telemetry, but it is also hooked up to our parachute events. So that will also be a backup system for deploying our 2 parachutes on board today. So that is obviously essential for safety. These are 2 off-the-shelf components that will guarantee, hopefully, that our parachutes come out and the rocket safely descends. We also have on board a tertiary flight computer made by Altus Metrum as well, called the Telemetrum. That is basically an Easy Mini with telemetry attached. So we personally here at CliffComms will not be receiving that data, but our retrieval teams on the boat will be. So they'll be using the GPS data that comes in from that as an extra data point in terms of tracking the rocket's landing location. We also have, this is my favorite, the Hamilton flight computer, which is a in-house built flight computer that we have spent the last few years working on in avionics as a non-flight critical, but very fun project. Completely built from scratch. Technical talk, it's a STM32 based microcontroller. It's programmed in the C programming language, gotta love it. And yeah, so that will be on board today. Very exciting that we get to fly that to such a high altitude. That is a really great opportunity.
So it's so good to try and explain the avionics system in a way that everyone's parents is going to understand, and also all the people from the UK Uni Rocketry who are just waiting to hear what microcontroller you're using.
Yes, and yeah, sorry.
Yeah. So the avionics is going to be responsible for deploying parachutes and passing telemetry back down to us here at the ground station. So for this graphic here shows us the general timings of the countdown procedures. So we have just been loading the Gryphon II. and are currently performing a final inspection of the launch rail and the vehicle itself before lifting the rail vertical. So what you're seeing there on your screen is a few of the technical leads stood around the rocket whilst it lays horizontally, and soon we'll be lifting that vertical. After that, we'll have a go-no-go pole for arming the rocket. At that point, we will be powering up the avionics systems, and we're essentially on a clock. Now, we reckon we can hold for about 4 hours and still maintain about 7-8 hours of post-flight recovery time. So we shouldn't be worrying about batteries today, but that's still a very important decision. At that point, we'll clear the launch site, arm the vehicle, arm the launch controller, and at T-0 we'll be launching. Now, from this graphic here, it would appear that we're still about 30 minutes away from launch, although I imagine that this will come quicker. From the rehearsals and the dress rehearsals we've been doing over the last few days, we have been moving through these final stages of the countdown quite quickly, so this is quite a pessimistic timeline. But if you are just joining us, we are preparing to lift the Gryphon II vertical and clear the launch site ready for launch. So we're just performing that final inspection. We have the site radios live streamed with us.
Cliff comms, this is Morgan. Can you call the boat at T-minus 10 minutes and tell them to get in position, please?
That was perfect timing.
Confirm. Yeah, we can do that.
So what you just heard there was our mission director Morgan radio up to Evan beside me here at Cliff
FYI,
comms.
Cliff comms, that would be Sky's number.
Copy. Thank you.
And tell us that we would need to be contacting the recovery boat out in the North Sea at T-minus 10 minutes, telling them to get into position. Now, the position they'll be moving to has been calculated by a long series of Monte Carlo simulations working with the RocketPi software. We've been running weather balloons today to monitor wind speeds and directions at different altitudes. And for the first time ever, this LURA launch is working with our very own in-house meteorologist, who has been working extremely hard to forecast the weather over the coming days and prepare us for this launch.
Yeah, this morning we actually sent out a weather balloon from our site to get more of an idea of the atmospheric environment up at 45,000 feet, which is something I don't think many other teams would do.
Yeah, it's the first time that we've done it, and I guess it suddenly becomes important now as we're going to higher altitudes. Obviously, in order to get the altitude record, we want our rocket flying as straight as possible and not cocking into the wind. But also, more than any other launch, we're really concerned with where this rocket is going to land. We need to get it out of the sea and get it into the boat, get the data off it as quickly as possible. So we'll be working from our vantage point on the cliff here to direct both the guys on the ground around the rocket and the recovery boat out in the North Sea, and try and get everything in position on time. So for what to expect, we're currently in the countdown. We've been working for the last probably 2 hours or so, setting everything up, working through the assembly procedures for the launch site, for the rockets, for the Cliff communication site where we are sat now, and getting the recovery boat in position. At T-0, which we estimate to be about 20 to 30 minutes from now, we will be launching and flying to, oh, that's just 34,000 feet, 43,000 feet. That's a typo there. If it's only that, we would be quite disappointed.
That would be disappointing, yeah.
From that point, the rocket will deploy its own parachute systems and glide down for a sea landing in the North Sea. We have a recovery boat already out there who we're in contact with, containing 2 members of our crew and a local guide, to go and collect the rocket. And we've been performing extensive testing in the lead up to this to ensure that the rocket is recoverable from sea. Evan, can you tell us a little bit about the testing that's gone into that?
Yes, so because this is such, well, it's quite a novel idea for an amateur team to go and try and recover a rocket from the ocean. Lots of testing was done. So, you know, kind of first round of testing is waterproofing, ensuring that the rocket is waterproof, which it is designed to be, which sounds maybe very simple. That is an extremely difficult task for lots and lots of reasons. But so yeah, we tested the waterproofing multiple times.
Harvey, this is James.
James, this is Harvey, over.
So I have just rang Ross at the MOD. We are all clear for a 3:45 launch. There is nobody in the danger zone. I have also rang Sky on the boat. They are in position, ready to receive the rocket.
Brilliant, James. As you can see, Sentinel is going up now. Hopefully we'll be ready to launch in 15 minutes.
Fantastic. I'm ringing the MOD back in another 10 minutes just to confirm that we're launching. But fingers crossed, really good job to all you guys on the ground.
Good job there. Well done. I'll get back to you with the status of whether we're going to make 3:45 or not very soon.
So Evan, this is the flight profile we're expecting to see today.
Yeah.
Can you talk us through that? I just need to adjust one of our cameras.
Okay, so yeah, this will give you an idea of the kind of flight path we should be expecting. So we'll be launching from off the bay, right by the coastline, up to the motor will ignite, and that will burn for anywhere from 2 to 4 seconds, probably somewhere in the middle of that. It is extremely high power motor with a very short burn time. So it will really, really accelerate off the pad. It will accelerate from 0 to Mach 2.5 in under 4 seconds. Do you have the miles per hour of that?
No, I don't. I guess we'll find out soon.
Very fast.
Very fast. And that is a technical term.
Yes, yeah, very, very. So yes, after the motor burns out, after those first few seconds, we will then enter the coast phase of our flight. And that is when the rocket is coasting its way up to its highest altitude. We will pass the 36,000 feet margin with the previous record, coast up to apogee 43,000 feet, where we'll deploy our first parachute, descend down to 500 meters, where we'll deploy the second parachute, and then it will touch down in the ocean.
And that's it. And that is a relatively standard profile for a rocket of this size, with the big difference being that we are landing in the sea. And that is really because we are so constrained on ranges available in the UK. It was so important from the very beginning of the Gryphon II project that we were going to fly and land in the UK, and the only way that we could do that at the altitudes that we need is in the sea. What we've just seen over the last couple minutes is that the ground teams have lifted our Sentinel launch rail vertically.
Ground station, this is Sentinel. G2 is in and raised.
And we've just heard that the Gryphon II is in Sentinel and ready. We're seeing a few ground crew members working on just tightening the tensioning straps that hold the silo launch in place. Behind me is an incredibly still and clear North Sea, and we are looking very good in terms of weather.
The boat disagree.
Oh.
We're just hearing from James who's been in touch with the guys on the boat.
Yeah, the boat do not think it's still. They think it's very rough. They were not happy on the phone, but they could suck it up.
I'm guessing that was our lot, not the fishermen.
Yeah, well, they said, I don't know how much longer the fishermen will let us be out here, and I was like, well, just hijack the boat. If you're already out there.
So we are coming up now to a final inspection and a go-no-go poll. Now, if you've been with us for a while and you're wondering when it's going to happen, we are getting close now, and once we see the site clear and the ground personnel that we're monitoring at the moment move away from the pad, things will start to happen very quickly. So do stay with us, because it will be blink and you miss it. While we just wait, I will have a sip of water. So Evan, during flight, we'll be monitoring the radio between you and the ground crew. What are we expecting to hear the call-outs?
During flight? So the main ones will be the different flight stages. So I'll be able to call events such as motor burnout, and also motor burnout into ascent, into apogee, into descent, into main parachute activation, into touchdown. Those are the main things to look out for, because they'll give us an indication of sort of where we are at with the flight. but I'll also be calling out data such as the altitude as we coast up. I'll of course be calling out the apogee as it comes, the big number that everyone wants to hear. And yeah, any interesting data that comes across. But that'll be the main data to look out for.
All right. So,
James, this is Harvey, over. We just had an issue with one of the Sentinel wires snapping. I expect this is going to delay us by probably 10 minutes. So looking now at a 3:55 launch, if that's all right.
okay, that's not good news, but it is a problem we can work through. What we've just heard there is that one of the tensioning wires for the Sentinel launch pad has snapped, and the ground crew have advised that it will likely set us back about 10 minutes to fix that problem. Unfortunately, with the amount that we have been rehearsing this launch and the run-up, that seems to have slightly fatigued. Now, we would never launch if we were not 100% confident that it was going to be safe to do so. So the ground crew just want a little bit more time to work on that. That will set us back 10 minutes. We're going to be monitoring the situation. We've got all the radios live on the live stream. If you've just joined us, we're waiting for the ground crew to just work through a quick problem with the pad. The rocket seems to be in perfect order.
Yep.
We're not monitoring any issues. The weather is looking good. And we're just having to liaise with the Ministry of Defence running the range and our boat out in the North Sea for recovery. Keep everyone updated. So we're going to be monitoring this over the next 10 minutes, but if you need a brew in the meantime, then probably now is the time to do that. We'll be just watching this quietly in the meantime.
Set us back another 10 minutes, so we're looking at 3:55 now. Once again, as soon as I know more, if I have any more updates, I will let you know. If there is no more delay, I'll give you a ring at 10:02, just to confirm the launch time.
Date that we've had an issue with the Sentinel straps and we're having to swap them out.
Cliff comms to Harvey. We confirm we have liaised with the MOD. We are now passing that on to the boat.
Brilliant, thank you, Cliff Comms.
While we just wait for that, I just want to take a moment to say thank you to our sponsors, because frankly, this operation has been massive. Building a rocket that is capable of beating the altitude record, testing it at 2 test flights, and then bringing a team of 20 people up to the very north tip of Scotland to rehearse, prepare, and inevitably launch that rocket is not a cheap endeavour. So this is just a quick, shameless plug to say thank you to our sponsors for helping us through that. What we can see at the moment is the ground crew just bringing the Sentinel back to horizontal while they work through an issue with one of the tensioning straps, which you can see laid out there. They're just quickly replacing that. So no major issue at the moment. We just want a little bit more time to work through that.
That's why we keep backups.
Absolutely. We always come prepared, especially, that is especially important where we are at the moment. If you've just joined us, we are coming to you from the very north tip of Scotland in a location known as Cape Wrath. It's a Ministry of Defence range that we are using for these few days. I'd like to take a moment just to touch on the logistical operation of bringing a team up here, working on the rocket, working on rehearsals, and then launching. Has been an insane operation. And frankly, just a massive thank you to Toshita, the head of operations at LURA, for running this with her team and being able to pull this together. Is there anything you want to add, Evan?
No, just that the whole team has done an incredible job. You know, previously we've spent a long time looking for launch sites. We've had some, they've fallen through. Getting this launch site secured and getting us all up here is an incredible feat that should be recognised. Also, to the flight dynamics and launch operations teams for getting permission to launch this from the CAA, the Civil Airspace Authority. Under the new system, we became the first amateur organisation to get one of these licences, and so this is a pretty big milestone for UK amateur rocketry.
That's a really good point. I mean, at this point, we're launching what's known as an N-class motor. This is beyond the limits of what you can launch with sort of amateur insurance as we would do our normal launches. So as Evan just touched on, we've had to obtain special permission from the Civil Aviation Authority to be able to fly. this is the first time, as you've just said, that any amateur has done this. So really the goal when we started the Gryphon II project was to pave the way for other UK teams. Most, if not all, UK teams attempting the flights at this sort of altitude will fly to the US. And admittedly, there may have been times this week where we've been wet through in a tent, hours from civilization, where we've considered
There's
that
a reason
option.
they go to the US.
James next to me has just pointed out that there is a reason that people go to the US. Nonetheless, the point of this project was to prove that you don't have to lay the groundwork, and we do intend to be making as much of the process that we used open source as possible to help other teams be able to follow in our footsteps. And to really help grow the competition between UK teams here with student rocketry.
Absolutely. There's no excuses anymore. If you're listening, we're going to set British records. I think we should do them from British soil.
Little boat update, by the way. Sky threw up on the boat.
Oh, bless.
Apparently, it's quite choppy.
Oh, bless her.
So,
unfortunately, ration packs, no sleep, and choppy sea do not go well together. So.
God, I thought we had it bad up here.
That's it.
they are not happy that we keep delaying launch, but you know, they'll be alright.
If you've just joined us, we have a recovery boat out in the North Sea waiting for the rocket to land after launch, and we've just had word that one of the team members has been a bit ill.
Bless her. Just while we're on the topic of shout-outs who made this possible, UKRA, the United Kingdom Rocketry Association, this would not be possible without them. So on the ground, not probably in camera, but on the ground down there is Chris from UKRA, who is our certified flyer today. So we are launching today with the TPS scheme, which essentially allows us to work with UKRA to launch higher power rockets than you would typically get licenses for as individuals. That is something that would make this, it would be incredibly hard to do this without the support of UKRA through that. So another thank you to them.
Yeah, that's right, Evan. I mean, UKRA have been amazing to work with, as always. We always make it a habit to include them early on in the design phase, and in fact, we sat down with them several years ago with a requirements document long before the actual rocket sort of came into existence. So we've been working with them for a long time, and it's amazing to have Chris here on the ground. I think he's just stood in the sort of top right of our frame with his arms crossed, watching over, ensuring that everything's done to a high standard and that our launch is as safe as possible. Just outside of the frame, and we won't adjust the camera because we'll probably mess it up, but just to the outside on the right hand side of the frame, what you can't see is that we have a
Clip
LURA
comms, this is
flag.
Harvey. We're just giving you a little update. We would really like to take our time with these final checks after we get Sentinel up. So we're going to be looking at more like a 4 launch would be what we're aiming for. Is that good with you, over?
Yeah.
Cliff comms to Harvey. Yep, that is okay with us. We will relay that to the MOD and to the boat again.
Brilliant, thanks for that, clip comms, over.
Okay, so we've just heard that the guys on the ground want to take a little bit more time with setting everything up and doing the final checks. It is really important for us not to get launch fever here. We have a 3-day launch window. This is day 1. So as much as we do want to get the rocket in the air today, and while conditions are favourable, there is no obligation for us to, and as long as that rocket is still on the ground, we still have many opportunities to take the altitude record. The last thing that we want to do is prematurely launch and waste this opportunity that we have, because it has been years in the making.
We only have one rocket, but we do have a few chances to fly it. So.
Absolutely.
Will do. Thank you, Ross. Bye-bye.
So we're just monitoring them. They have fixed the problem with the strap on the Sentinel. We can see 4 tensioning straps now held out. They are bringing the rocket vertical on the pad, and we've just heard that they just want a little bit more time to do final inspections, make sure everything is thoroughly ready before we move forward. Just to our left, we've got James Raven from the team on the phone to the ill boat crew who are out there on choppy seas and have been, I think, for several hours now.
I don't think it's quite that long. I think it's been about an hour and a bit.
You
but,
think they're exaggerating?
No. Because they're going to watch this back. That is not the claim I'm making.
So James is James is having a tough conversation with them at the moment. Seems to be resolved, so we are just waiting a little bit longer. I'm afraid, sorry for the wait. If this is the first Rocketry live stream that you've seen, this is extremely normal. We like to take our time with things. We have several pages of procedures sat on my lap that go from T-3 hours all the way to sort of T+2 hours. So we are working to a schedule. At each step we have strict requirements before progressing on to the next. So we want to make sure that everything is absolutely ticked off and give Gryphon II every opportunity we possibly can to have a successful flight and recovery. If you are just joining us, we are aiming to beat the UK amateur altitude record today and fly to an altitude of 43,000 feet above Cape Wrath in Scotland. Not only will this be the highest a UK team has flown, it will also be the first time that a UK student team has attempted a sea recovery. And in fact, even our UKRA mentor Chris here on the ground with us today admits that he has never attempted this feat. Whether we will regret it or not is yet to be seen. All I can promise you is that either way it will be exciting.
What a place to do it.
It's a shame that you can't see all the way around behind us because the ocean at the moment is just gorgeous. I'm going to see if I can pull up a camera for you to show you that. We are sat on a cliff and I'll see if I can pull that up. Just bear with me.
Mao's Tyler, can you please swap the control and
There we
center
go.
line?
So this is the view out from behind where we're sat. You can see we're just under a canopy. on
Maru,
top
this
of
is
the
Harvey.
cliff. Apologies
Tyler's
for
quite
the
busy at the
shaky
moment.
filming.
What
With
is
the
he
North
doing?
Sea looking clear and calm behind
Swap
us.
control and sense lines on the pad box. Very quick job.
Harvey to Maru. Morgan is doing that now.
Just a little bit of radio chatter as we approach launch here. The rocket is vertical and they are currently
Lines have been swapped.
final inspections on the rocket and the
You're
Sentinel.
the goat, thank you.
Sentinel being our own in-house built custom launch rail. Now, what's special about Sentinel, Evan?
Sentinel is special in the sense that it doesn't have what are called launch buttons. So typically, a launch rail consists of one straight pole, essentially, with a slit cut out, and the rocket would have buttons on the side of it. These kind of these little knobs that would stick into that gap, and then you'd load the rocket in like that, and then that way it can stay attached to the rail during liftoff. The problem with that is that it increases drag because those launch buttons have drag to them. So Sentinel is a launch buttonless design in that it consists of 4 poles, and the rocket slides into the middle without anything necessarily securing it. It just stays firmly placed in between these 4 poles. It is also designed to be very easy to transport. It flat packs down. It's kind of like building IKEA furniture once you get used to it. And then, yeah, we can pull it up to locations like this, up here in Cape Wrath.
Absolutely right. Yeah. So the drag saving on the rocket is quite considerable by not having additional components protrude from the sort of outer mold line of the vehicle. Yeah, absolutely right. We've been able to get around that with this design, and it's been flown many times now. Is this the 3rd flight with it?
Yeah, this will be the 3rd flight with Sentinel, yes.
And probably the 20th or 30th time that it's been assembled for
God.
various mock launches.
That might be on the underside.
Yeah, so that's why we just were working through an issue with one of the tensioning straps that you can see on the screen there. Obviously just getting a little bit worn out, maybe a little bit of seawater wearing it out as well. The challenges over the last few days have been incredibly, the conditions over the last few days have been incredibly challenging with high winds, salty winds, and really cold temperatures. We are currently so north in Scotland that we really only get nighttime for about an hour or so. That makes our team very productive, but means that we're all absolutely exhausted because you kind of look around, you're still working and barely realise that it's gone midnight. At the moment the weather's looking good though. We have a little bit of mist out to our left, but to our right and behind us it is clear, and that is the flight path of the rocket. We'll be hoping to maintain telemetry contact with the rocket from the moment that it lifts off right through to recovery. Although with the terrain here and large cliffs and the fact that the rocket is flying at such an altitude that the actual recovery site is several kilometers away from here, that may be unlikely. We'll be doing our best to keep up to date with it, and we'll be in contact with the boat crew, and we'll be trying to keep you updated. After the launch, we will maybe answer any questions if there are some in the chat and talk through what we've just seen. And then it's likely that we'll pause the stream, as it may take quite a considerable amount of time to recover the rocket. We'll keep some text-based updates up on the screen, so at that point after the launch, feel free to tune in and out, and keep one eye out, and then hopefully we'll either restart the stream or provide an update once we've got hold of the rocket.
Yep.
Now, why is it so important that we recover the rocket here today, Evan?
So there's lots of reasons we want to recover the rocket. The first and foremost being that we're very proud of it. It's very expensive to make. Anyone who's been in the School of Mechanical Engineering building at the University of Leeds, if you look up as you walk in, you'll see Gryphon I hanging from the rafters. And honestly, every time I walk past it, I feel very proud. And we plan on putting Gryphon II in a separate place next to it when this is done, if we get it back. The second reason is that we have to, in order to get the record. So you can't just put a motor on the end of a nose cone, add some fins, and send it up and say that you got the record. You have to retrieve the rocket, and it has to be in an acceptable state that it could be reused with minimal maintenance. So that's the goal. And Chris and people from UKRA will look at that. They'll look at our data, and they'll evaluate that we've met the conditions to have the record.
Absolutely right. So as long as we maintain telemetry with the rocket during the flight today, we hope to update you on whether we believe we have hit the record, or really what altitude we think we have reached today. However, the actual record is going to be dependent on a successful recovery, and UKRA going through the data to ensure that we have actually met that record. So we won't be able to confirm that today, especially because we are so remote that it will take some time to be able to get them that data to review. And our sea recovery team will be landing at a separate site to where we are currently. But we do hope to know from telemetry how high we have reached.
It is possible. We have a scenario wherein I have a maximum altitude that does look a little low, and
Harvey, this is James. James, this is Harvey, over.
Are we still go for a 4:05 launch?
Could you repeat that, sorry?
Are we still go for a 4:05 launch?
James, I'll be honest, things take a bit longer here than expected. I would imagine it's going to go up to 4:15.
Instead of doing consistent 10-minute delays, could we delay it longer if we need longer?
I think the opinion is that 4:15 we should be able to make, and Morgan would have to rerun his simulations again if we get past that. So we don't really want to go past that limit. But yeah, that would be our absolute limit, I think, in the current moment.
Okay, thank you.
So we've just been hearing a bit of chatter between James, who is liaising with the range control and our recovery boat at sea, and Harvey, our vehicle director, working down at the pad to ensure the Gryphon II is ready for launch. Now, we are hoping to fly today. There is no indication so far that we won't be flying today, although it is worth bearing in mind that Rocketry is always full of delays, and still at any point the team on the ground or up here at Mission Control may decide that we are not going to move ahead with the launch. We have a 3-day launch window, so 2 more days after this in which we can get the rocket in the air. We do not want to waste this opportunity, and that is why, if you are a little bit fed up with how long you're having to wait, that is why we are taking that time to ensure that everything is in order.
It is what happens all the time with these launches. Got 4:15, and then I'll let you know again 10 minutes before it's going to change. Fantastic. All right. Cheers. Thank you, Ross.
Now, the less glamorous element of this whole operation is that we are getting bitten alive by little midges. I don't even know if they're biting me, but they're crawling all over me.
Yeah, it's horrible. I've got some bug spray.
As much as we don't want to catch launch fever, we do want to get this rocket in the air so we can get back to a nice comfy bed and
yes,
a shower,
please.
which we are still probably several days away from with a long journey back to Leeds. So we're currently monitoring the group on the grounds, performing final inspections, making sure they're 100% happy. We can see our UKRA flyer of record, Chris, in the blue just to the left of the pad. He seems to be inspecting something, making sure he is very happy with everything before we go ahead. Now, once we move past this stage, which we've had a little trouble with so far, we're going to be going to a go-no-go poll, where you will hear over the radio, we will circulate through different members of the team and ensure that everyone is happy with proceeding with arming the rocket and inevitably launching. So that will go through Maggie, our flight dynamics, Harry, recovery, Jack from Avionics, James from Aero, Manon, our Sentinel rep, and Evan sat next to me here at Cliff Communications, who will be monitoring the telemetry. Oh, apologies. In addition, that will actually, I've just turned the page and seen the list goes on. And we'll expect a few minutes for this go-no-go poll. We'll then also go to Sky, who's in the vehicle recovery boat. She won't be on radio, so that might be done separately over the phone. So far as we can tell at the moment, she is go for that. And then finally, the final go-no-goes will go for Harvey, our vehicle specialist, who's responsible for the Gryphon II rocket as a whole, and Morgan, our mission director, who's been doing a lot of work on the flight dynamics and modelling and ensuring that the whole operation runs smoothly. So we'll be progressing to that go-no-go poll as soon as we hear over the radio that they are happy with the pad construction and mating. As far as we're aware, they're not working through a specific problem. They are just being thorough, making sure that we do not lose this opportunity to attempt to beat the UK amateur altitude record. When this thing does lift off, it is going to be incredibly fast. The camera feed that you're seeing at the moment, just before launch, we're going to be zooming that out to a much wider view. We're going to try and have a tracking camera, although anyone who has been to one of these launches before knows it is extremely difficult to keep track of these rockets. So a little bit of imagination may be required. The rocket itself will accelerate to a maximum speed of 2.6 times the speed of sound, or Mach 2.6, and it will do so burning 9 kilograms of fuel in 3.6 seconds. So that is pretty fast. I mean, we've just done the conversion here. I mean, as a rough estimate, we're talking 2,000 miles an hour in 3.6 seconds. So we're not going to beat ourselves up if we can't keep track of that. All of us here at the Cliff Communications site are just having a bit of a giggle at the prospect of that. Burning 3 kilograms of fuel a second is pretty fast.
It's not often we see it in the human numbers, is it?
Yeah.
Miles per hour is a lot different to Mach. Oh my god, okay.
Yeah, so the rocket will accelerate to about 2,000 miles an hour in about 3.6 seconds. After that, we're really relying on the sleek, long aerodynamic shape of the Gryphon II, because it will be coasting from that point all the way up to 43,000 feet. It will be doing that unpowered and using its passive aerodynamic stability to stay in the correct orientation. As we looked at earlier, let me see if I can pull that up again. As we looked at earlier, after we reach apogee at 43,000 feet, we will pop the drogue parachute, which is the smaller of its two parachutes, 0.9 meter diameter. The rocket will be in two interconnected sections at that point, having released the nose cone to eject the drogue parachute, and it will drift down all the way down to 500 meters above sea level, where the main parachute will then deploy much larger parachute at 2.4 meter diameter, hoping to just kiss the North Sea at 5 meters per second. And if all of that goes well and our modeling has been correct, we will have a boat out in the North Sea with some of the LURA team members ready to collect the rocket and bring it back to the land ready for analysis. If everything goes right, we will be getting more information this evening that we'll be able to keep everyone updated with on our social media. So if you haven't already, now is the perfect time to make sure you're following at Leeds Rocketry on Instagram, on Facebook, on LinkedIn, and making sure that you've got notifications set on so that you'll be notified when we're posting updates, maybe live streaming later in the day if we have specific updates.
Harvey, this is James.
This is Harvey, over.
Still good for 4:15?
Yeah, we think we can make it. Sentinel is now at the optimal inclination. We're just going to run our final little scan of G2, insert the igniter, and then we'll be good for arming, hopefully.
Awesome stuff. Let me know if that changes, please.
So we seem to be on time, which is good news because I am hungry.
Yes, me too. We had a bit of an expedited setup, then we skipped lunch up here.
I have a weird craving for Jamaica cake. So we're seeing... Oh, we have lost the video feed. Apologies for that. One of our crew members is just going to press the button that will bring it back. And we are back. What we have just seen, unfortunately we've just missed it, and that's my bad, is crew members moving away from the pad. We just have a few left around it from a final inspection, and we are imminently awaiting a radio call for a go-no-go pole to arm the vehicle. Evan, just quickly, can you remind us what is arming for those that are not used to rocketry terms?
So, the rocket, as it currently exists, is a fully integrated vehicle. That means it includes all of the batteries that are powering all of the different components inside. However, because we've assembled the rocket about an hour and a half ago, the batteries have a limited capacity, which means you don't necessarily want all those components running all of the time. That's the secondary reason. The main reason is also for safety. So those flight computers inside are hooked up to ejection chargers to deploy the nose cone so that the parachutes can come out. And while people are sat around working on it, you don't want that to accidentally fire off and potentially injure someone. So rockets of this scale typically have a process called arming, which is by which you can essentially turn on the flight computers after the rocket has been fully integrated together. So for us, that is 4 jacks around the outside of the rocket, where we put in these plugs, and while they are in, the electronics inside are off. They are removed before flight tags, so we will not forget to remove them. And then right before launch, which we're coming up to soon, we will step through them. We will remove one each at a time and validate that the electronics have turned on properly. And that will mean that the rocket is ready to fly after it has been armed.
So I'm not sure if we can see on our screen, might be just a little bit far away. We're up at our high vantage point to ensure that we have best chance of maintaining telemetry. But you might just catch a glimpse of those 4 red removed before flight tags. Once we have the go-no-go pole, providing that everyone's happy to move forward with the countdown, then we'll have our avionics crew working through that. And you'll be hearing a dialogue between our avionics crew on the pad, speaking with Evan sat next to me here, working our ground control station. What will that dialogue be about, Evan? What will we be looking for?
So they will make contact with me, and they will they will inform me of different actions they're taking. So for example, they will say we are removing the primary power arming switch. They will remove it. They will validate that it sounds correct on their end because the electronics are configured to beep if they are working correctly.
So it is actually just listening for beeps on the pad?
Part of it is putting your ear to the rocket and making sure that it sounds correct. But then they will relay that to me, and then I will be picking up the telemetry. So then I will connect to them remotely, check the telemetry feed, and then I will confirm to them that it looks armed correctly on my side too.
Perfect. So we'll be keeping an ear out for that. When we have the approval, the go for arming, we'll be shutting up here in the commentary, and we'll just be listening to that radio dialogue back and forth. So we'll be listening for the primary and secondary flight computers, which will be the Fluctus and the Easy Mini and the Hamilton flight computer. And so we'll be listening out for those specific keywords between Evan and the Avionics crew on the ground. Now we're seeing more and more team members move away from the pad at the moment, which is a very good sign at this stage. The radios are quiet, which indicates that there isn't an issue so far, and that we are imminently awaiting to move towards the go, no go pole. If you have just joined us, we are hopefully in the order of about 15 minutes away from launching to the highest altitude that any amateur in the UK has ever
Ground crew,
successfully
update
launched.
please for Cliff comms. Igniter is in, attaching tomorrow any second now. We will keep updating every
To put that number into perspective, the 43,000 feet,
Fantastic. I
that
will
is
contact the
pretty
MOD.
similar to the typical cruising altitude of a passenger plane.
Igniter going in.
Oh, okay.
We've just had confirmation from the ground crew that the igniter for the solid rocket engine is being installed, being connected to our ground station, which we will be referring to as Maru. So you'll be keeping an ear out on the radio for that as well. James here is just liaising with the Ministry of Defence, keeping everyone up to date and in the loop. As we see what looks like just 4 crew members around the rocket at this stage, checking the arming switches. We're just imminently awaiting a radio call to go ahead with arming. Arming the rocket is the last difficult stage gate, if you like. A few things can go wrong there if the computer systems have an issue. Is that correct?
Yep, it would look that way.
So we're just waiting for that now.
Ship pins have been removed. Moving on to arming pins. Ground station standby for telemetry.
Here we go. We're going to start arming. So we are just going to listen to the radio for the next few minutes.
Evan, confirm you're ready for switch on. Confirm, I'm ready. Right, can we get go no go from everyone please? Ground station, are you ready? This is Cliff comms. Are you referring to Cliff comms being ready? Yes. Go no go, are you ready? No go, I'm still connecting to the flight computer. I'm doing no go before removing arming pins. My bad, I got confused. I'm go. Right, Morgan, are you go no go?
Yeah, I'm go.
Removing Fluctus now, please confirm. Stand by. Confirm, we have Fluctus. Perfect. Moving on to Easy Mini, you will not receive anything. We'll check beeps. moving on to telemetrum on the tertiary. Telemetrum armed, please confirm. I cannot confirm that the telemetrum is armed, because I do not have the tele-PT here anymore. No worries, it is working with beeps. I'm removing the arming pin for events now. Can we hold? I have not received Fluctus since we first confirmed it, so I would like to restart my ground station up here and see if I can get a better connection. Confirm, carry on, we can still hear the beep, so we're not too worried. Fins have been aligned. Any updates, Evan? Can confirm I have a better connection with the Fluctus now. We are attaching the igniter.
Cliff comms, this is viewing area. Do you want to call recovery just to confirm they're okay?
Confirm we have called recovery and MOD and told them both that we're good. Okay, we're starting countdown soon. Please keep radio quiet and let us hold now, please. Thank you.
Things up after removing the arming pin.
Yes, confirm. Rocket is live. We're now heading back to Maru for ignition.
Okay, so we have just heard
Do you need
that
to do
we
something
have
else?
armed the
From them?
rocket.
I can see.
So we are going to get the camera ready for launch now. So just bear with us for a moment. We're just going to listen to the radio. So you can see that we have telemetry readouts at the bottom of the live stream. There is no guarantee in true student rocketry fashion that we will see anything there. It doesn't necessarily mean that we've lost contact with the rocket. So just be aware of that. We won't necessarily be alarmed if we can't see that. Just going to adjust the camera a little bit. See what we can see. We are still awaiting a final go, no go.
To be honest, pointing out's probably going to do most of the job. I'll let you know, but remember that you're connected here.
Now, the rocket is going to move extremely quickly. Just remembering what we were saying earlier, it is going to accelerate over the course of 3.6 seconds to 2.6 times the speed of
Right, final no-go, no-go, please.
Here we go, final no-go.
Recovery is go. FD is go. Vehicle specialist is go. Cliff comms is go. Avionics is go. Aerostructures?
Aerostructures is go.
Sentinel is a go.
And we have confirmed that boat is a go.
Here we go. 3 years in the making. LURA is going to attempt to beat the UK amateur altitude record. Whatever happens when we press the launch button, we are incredibly proud of all the efforts and all of the many people that have worked on this project. Whatever happens when we ignite the rocket, as long as it ignites, I can promise you, it will be loud.
Countdown is
it will
starting
be
now.
fast,
I will turn
and
off
it will be
radio at 3
exciting.
seconds, so there's still a chance for a no-go. Okay?
Here we go. Let's listen.
Ready?
now.
Okay, we are go for launch. And we are going in 5, 4, 3, 2, 1. Max acceleration 25 Gs.
That was a successful ascent. We lost telemetry readout on the live stream, but we're not worried about that. We are still tracking the rocket.
I have not had telemetry since launch.
Heads up, coming down.
I think we lost a fin.
We lost a fin.
Drogue!
Drogue deploy! Confirm drogue deploy!
It appears there may have been an issue during the launch. We're just going to listen into the radios.
Cliff comms believes
We saw drogue. Visually.
I have visual. Not the rest of the rocket. Drogue has a visual. Why would you call that? There's no rocket attached to it. Why? Because I saw flashes.
We have the rocket landed. We see drogue and main, but we saw something come down ballistic. We saw just a parachute. We believe there was a failure.
So by the sounds of it, unfortunately, the Gryphon II launch today has been unsuccessful in achieving its aims of beating the UK amateur altitude record. We are still waiting for confirmation as we figure out what happened. We did see a parachute, but much earlier than we would expect to, and it seems that at least a part of the rocket came down ballistically, i.e. either untethered from the rest of the rocket or without a full parachute deployment. So we have quite a lot to figure out at the moment. We're going to keep one ear into the radio in the meantime and try and keep you all updated. But yeah, if you're just joining us, unfortunately, it seems that the Gryphon II flight today
Cliff comms, can you please update recovery team they can stand down? We will go get the rocket.
successful.
Yep, I believe that we are already doing that. I mean, to be fair, you're probably closest to the rocket, actually.
see the parachute.
Guys walking from viewing, just be really careful because there is like a, you know, small river and stuff. Please. You know what I mean? Yeah, we have radios.
So unfortunately it does seem that we lost the Gryphon II shortly after takeoff, although ascent at first glance seemed okay. We have multiple different reports that at least elements of the rocket may have come back to the ground ballistically, i.e. not under their parachute. We have seen elements of parachute come down, so we're currently just dispersing our ground crew teams to go and investigate that and see what we can find. Hopefully we'll be putting updates on social media over the coming days as we work through a thorough investigation and figure out what exactly happened so that we can learn from it, continue to build on it for future rockets. But yeah, if you're just joining us, unfortunately, we've been unsuccessful today. It is not, the first failure that the team has faced. This is an incredibly strong team at the moment, so it'll be very impressive to see how they can bring themselves back from this, continue to build on what they've learned, and come back stronger in the future. I think it still can't be understated the massive achievement in even getting here. No UK team has even attempted a high altitude launch like this from the UK soil. So even getting here alone is a major achievement and something the team should be incredibly proud of. We're likely going to end the stream here. We have ground crew spread across the Cape at the moment, searching for elements of the rocket. We're hoping really to retrieve significant enough elements of the rocket to determine what happened during flight, what caused the failure, and hopefully retrieve the onboard data recorders that will help paint a little bit more of a clear picture, as we didn't receive very much telemetry during the ascent at all. Thank you for being with us over the course of the last hour or so. Hope you found it exciting, and that is the beauty of student rocketry, is that no matter what happens, it is always loud, it is always fast, and it is always exciting, and we have definitely hit that today. So the team is now going to work on a thorough investigation, figure out what happened, implement fixes, and decide what to do next. But yeah, in the meantime, thank you for the support. We hope you enjoyed the live stream, and we'll see you again at the next one.